afternoon, everyone. Thanks for joining in. Thanks for joining the Tool Talk session, which is happening after a gap of 3-4 months. And this is Nishant, editor of Tagma Times magazine, and your host for today's session. And today's topic is all about EV and what kind of demand it is going to create for the tool maker. So, as we all know, that the biggest buzzword in the global automotive industry is all about EV. And leading from the front is the two-wheelers. So as we know, according to the reports of IMARC Group, the Indian electric two-wheeler market is projected to grow at CAGR of about 44% during 23 to 28. So in today's session, we are going to explore the trends that are shaping up in the EV industry, the kind of demand it is going to create for the tool makers, what OEMs like Ather Energy expects from the tool makers, and what kind of challenges we are going to face. And to discuss all this thing, we have our distinguished guest, Mr. Ramesh KS. He's a Senior Vice President at Ather Energy. Welcome, Mr. Ramesh.
Thank you very much, Nishant, and good afternoon, everyone. Thank you, Nishant, for the opportunity. And
Thank you
great
so much.
meeting everybody in this forum.
Thank you. Thank you. Now, I would like to request Mr. Shanmugasundaram, Vice President of Tagma India, to say a few words about Mr. Ramesh. Mr. Shan, over to you.
Yeah. Good evening to all, and a very pleasant evening. First of all, I would like to thank all the Tagma members who has re-elected us the same team of last year, and a few more new AC members. I welcome all the new AC members from Hyderabad, Bangalore, Pune. And thank you, Ramesh, for spending time with us for this interactive session. About Ramesh KS, he is an accomplished professional with over 30 years of rich experience. Armed with a mechanical engineering degree and an MBA in finance, Ramesh has carved a successful career path that spans across various domains. With an impressive 25-year tenure in the auto industry, he has gained extensive knowledge and insights in the field. Currently, Mr. Ramesh is serving as a Senior Vice President of Engineering and Manufacturing at Ather Energy. Ramesh plays an important role in driving the company's success. Prior to joining Ather, he made a significant contribution during his tenure with prominent organizations like Renner, Fortive, and Visteon. Throughout this journey, Ramesh has demonstrated exceptional leadership skills and a sharp business acumen. With more than 12 years of experience in running businesses and managing P&L, he has established himself as a strategic leader. His expertise spans across the various areas, including operational management, engineering, business development, sourcing, and supply chain. Once again, thank you, Mr. Ramesh. Let's have a very good interactive session. We are all eager to listen to you. Thank you so much.
Thank you very much for the kind words, and congratulations for getting re-elected.
Thank you, sir. Thank you.
Thank you, Mr. Shah. So, shall we start, Mr. Ramesh?
Sure, of course, Nishant.
So, just to set the tone, Mr. Ramesh, if you can speak about your company and specifically about the tooling division, what kind of tools you required, where exactly you are sourcing it from. So, if you can just talk about your company and the tooling division.
Sure. I'll quickly give a brief about Ather before we start. Ather, this year we are completing 10 years of inception. Of course, this is started by two grads out of IIT Madras, Tarun Mehta and Swapnil Jain, and we are completing 10 years. They started this company in 2013. It was incubated in IIT Madras, and we carry the name Ather Energy because it was originally conceptualized as an energy company using lithium-ion based battery. Right. Eventually, the two-wheeler was conceived as a way to demonstrate where this can be used, and that became our core business. I think we will remain to be a two-wheeler manufacturer for the next probably 7 to 8 years before we expand ourselves into other areas of energy. Right? The first 5 years were gone into developing the product. We brought our product to the market in 2018, and we have been progressively growing. We started with Bangalore, then we introduced it into Chennai, and now we are present all around the country. We got around 150 outlets and we are continuously expanding. We are also the single largest provider of fast charging. Every city we go to, we already put the fast chargers for the consumers to use. At this point of time, we have more than 7,700 fast charging outlets around the country. Um, that's about us, and we are very, very fast growing. If you see on the two-wheeler, the EV two-wheeler is making a revolution in the two-wheeler market. A couple of things are happening about electric vehicle. The starting point is to say it's an electric vehicle. I'm sorry, I think I realize I'm running out of battery. I probably have to run to pick my battery charger. Um, what's happening, what EV is doing to the two-wheeler industry is what happened in the cell phone industry. What I mean to say is earlier it was a Symbian platform based handsets with no touchscreen, some things like that, right? And the Android platform, the iOS platform revolutionized the handsets. The technology moved up, and where people are ready to spend 2,000 rupees on a cell phone, today everybody lands up spending anywhere between 8,000 to probably a lakh or more, right? So it
Right,
moved up
right.
the market, it moved up the aspirations of people. So that's happening in two-wheeler industry. So the electric vehicle not only offers you a different prime mover instead of ICE internal combustion engine, it is driven by electric motor, but the features, the experience that the customer expects out of an electric vehicle is very different. So it's revolutionizing the user experience, and it's also increasing the feature content of the vehicle. So that's a major change that's happening in terms of revolutionizing the untapped need of the customers.
Okay. And would you like to add a little bit more about your tooling division, specifically the kind of tools you source, tools you manufacture?
Just a minute. Yeah, Nishan, just a minute.
Yeah.
I'm sorry. I was
No
talking to
problem.
somebody to change my battery cable. I'm sorry about it.
No problem. Yeah.
And my I got a before I talk about the tooling, I got a high-end laptop, but the batteries are not as good as the batteries we make. It's got a very short life in my battery, and it suddenly runs out. It's not like the vehicles we make. Sorry about that. Yes, we have a. I got a very good opening statement as what we do as respect to tooling, because we don't do import any tooling. All
Oh,
the
wow.
toolings we need are sourced from India. But having said that, all the tools that we use may not be made in India. For example, fortunately or unfortunately, almost all the toolings made by lamp suppliers. We have got multiple lamp suppliers, and invariably our lamp suppliers imports the tooling from China, Taiwan, or Korea, right? Uh,
Okay.
so there is some, excuse me, just a minute, sorry. Yep, my power is back. So,
Yes.
unfortunately, as much as we want our direct buying and indirect buying of tooling to be from India, so there are some pockets of tools that are imported indirectly by our suppliers. And we are continuously urging our lamp suppliers. I'm using the word specifically lamps because I had been in lamp industry before, and even when I was in lamp industry, I used to import tooling, uh, unfortunately, for the tooling. Right? I think that's an area India is still importing tools. Otherwise, all our tools are made locally. Okay, whether it's casting, whether it is plastic tools. There are a lot of these lamination tools, high-end tools that our suppliers use for motor manufacturing. The rotor and the stator lamination tools, those continues to be imported by our suppliers,
Right.
and some in some cases some special tools like uh, uh, sintering tools are imported. But the good news to the industry is most of the high volume tools, 80% of the tools are made in India.
Nice, nice. Good to know that 80% is made in India, and I hope in a couple of years we'll be doing 100% from India.
Sure, that's my aspiration also.
That's great. So, As last week there was a news about BIS has approved Ather developed connector as a new charging standard for light EVs in India. Also,
Right.
it talks a lot about your R&D activities. And a few days back on LinkedIn platform, I saw co-founder Mr. Tarun Mehta is speaking about Ather having world's one of the largest R&D team. So would you like to talk a little bit more about your R&D activities, about bringing
Sure.
this kind of a battery and the vehicle that you make?
Sure. So there are many views about Ather's engineering, where it comes from in the market.
Right.
I don't know if the complete industry knows about where the engineering comes from, right? If you take some other companies, for example, right, Ola's primary engineering came from a company called Ethergo. Ethergo is a European company which Ola acquired, and that's where the primary engineering came from. As I was telling you in the beginning, right? We started in 2013, but we came to the market only in 2018. The reason is it was a ground up engineering. Every part of the vehicle is completely engineered out of India by homegrown teams, right? That makes it the biggest uh, uh, engineering teams that for two wheelers in India, right? Having said that, you may ask the question, why does it make the biggest team? If you really look at a dashboard or the instrument cluster that you see in a Ather vehicle, it's a completely high-end touchscreen dashboard with navigation, with a TFT display, right? This is not a product that is normally available for a two-wheeler industry. Even those modules are completely engineered, including the software. Everything was engineered in within Ather, right? If we talk about motor, the motor is a brushless DC motor, and the technology dictates that to drive a brushless DC motor, you need to have an electronic controller to make it work. And if you want to have different drive modes, you need to have a motor drive controller with a lot of embedded software to drive it. So,
Right, right,
everything right from the scooter and the ecosystem of the scooter with this charging system, everything is homegrown technology. Whether it's hardware, software, or mechanical engineering, it's all homegrown. And it's a sunrise industry, right? Many parts of the scooter are not the same. Uh, the starting point we say is the engine is replaced by a motor, okay? But I'll give you other
right,
points. Like, for example, you have a switch. Many of the switches will have copper contacts, whereas we use micro switches because we don't want the switches to draw power, right? Whatever power you put on the battery pack, we want to use it only for the motor, right? So every aspect of the vehicle is specially designed for EV, and that's homegrown. That's
right.
why it makes it a very big engineering team. Coming to the charger you spoke about, we have developed a unique AC DC combined charger.
Okay.
And India did not have a standard for charging connectors. We worked with the government to make our connector Indian standard. But having said that, even though we had a patent for it, we have opened up the patent to all other OEMs. So everybody can use this connector technology, can use the same connector configuration. So we don't want to hold back. We want to give it back to the industry so that we grow as an industry. So that's what we want to do. And we encourage more and more two-wheeler companies to use our same connector platform so that, and the connector is made by one of the suppliers, not that we make any revenue out of it. So that we have an industry standard, we are able to provide better services to the customer as a whole.
So, sharing the patent for the betterment of industry is great thing. Nice to know, Mr. Ramesh. So, my next question is, you have years of experience in automotive industry where you have worked with IC industry, and then now you are leading the supply chain and manufacturing division of Ather Energy, which is also one of the prominent name in the EV industry. So, what are the unique challenges and opportunities of a tooling division working these two different environment in a IC engine, the conventional and the EV?
So if you talk about two-wheelers, we'll talk about two-wheelers and I will take the liberty of talking a little bit about the four-wheeler also, right?
Right.
Uh, both the two-wheelers and four-wheelers, as I told you, it doesn't stop by just saying I want to remove the um engine with an electric motor and a controller, right? With this more and more electronic software getting embedded in the vehicle, there is an effort towards providing greater experience, a different user experience. So every part of the vehicle there is a thought process about redefining it. Okay. If you
Yeah.
talk more about the electric two-wheelers, definitely we want to make the vehicle as lighter as possible so that one of the most expensive part of the vehicle is your battery pack. Okay.
Right.
Uh, Nearly 35% of the BOM is just your battery, right? So it's a very premium portion of the vehicle, and we want to ensure that every ounce of energy that you put there is used to go for the range, and so we want to make the vehicle as light as possible, right? So
Right.
the first platform we came out with has got a complete aluminum body. The
Okay.
complete chassis is aluminum, so that we attempted to make it as light as possible, so your range can be higher. Okay, and all the complete body parts are plastic, right? So there is the plastic parts makes it lighter, tougher. Plastic doesn't mean it's necessarily cheap and it'll break. It is actually not. It's a misconception. You from the industry will know when I say plastic is better. Sometimes you will recognize what I'm talking about, right? It's lighter, but it can also get tougher, and it provides a lot of opportunity to provide unique features and have different styling in the body panels, right? So there's a lot more opportunity for plastic tooling to happen on the body panels. And our current platform, which is primarily casting, instead of a tubular structure, we use a lot of casting. Okay, we initially used LPDC, now we are using HPDC. So there's a lot of opportunities in lightweighting the vehicle, which means a lot more opportunity for the casting tooling developers, right? If you look at Tesla, I'm sure even the four wheelers are going to do what Tesla is doing, right? Tesla
Right.
has made casting, where the complete body they are casting is one casting. So I think the EV as a segment, whether it's a two-wheeler or a four-wheeler globally, is also changing the way we build vehicles, the changing the way in which we are conceptualizing a vehicle and building a vehicle, right? And incidentally, that's going to the benefit of tool makers, tool
Okay.
rooms, right? So I think there's a lot of opportunity. The other challenges, because of the intricacies and the stack-ups, the tolerances are becoming narrower and narrower.
Okay.
So the last few days, I have been trying to moderate between my engineering team and my manufacturing engineering team and tooling team to achieve certain tolerances on a cell holder, which at
Right.
this point of time seems unachievable, right? The tolerances are extremely close. The positional tolerances, the warpages, the demand on those are going up. So that
Right.
is forcing us to think about some of the technologies we keep thinking about in the past, but we have not made it a reality. Like, for example, in Tagma meet last time, somebody made a presentation about aluminum tools, right?
Right.
And we're now actively exploring to say that, hey, can I use those aluminum to have enhanced cooling in certain parts of the tool, right? So there is a need for all of us to work together to marry different technologies that we come across. The aluminum sliders or aluminum portions of the tool that we are trying to explore now is an example of what we learned recently from the Tagma workshop, right? Uh,
Nice.
People have been talking about conformal cooling for a long time, but the industry has not really picked it up. But those are things that we are right now picking up a lot, right? So what is happening is the accuracies and the dimensional tolerances and the variability that we can permit is going down, which is forcing all of us to think deeper into what kind of technology we can put in the tooling, right? How you can bring the advanced tooling techniques into the making tools.
That's great. And a few minutes back you spoke about 80% tools are sourced from the Indian companies and about 20% are sourced from the Taiwan, China, Korea by your suppliers. So at Ather, what specific factors are considered when sourcing tools and dies for your in-house need? What kind of evaluation factors and what do you see in that particular tool room before you onboard them as your vendor?
Sure. Before I talk about this, I want to break a myth that based on what I work in Ather before, based on the work I did in Ather in Visteon, which is intensive on interiors. Uh, Tool room strongly believes that there are different quality of tool rooms, and the customers do not appreciate the subtle differences in technology a tool room cannot provide. which may not be completely true, right? Of course, when we sit on the sourcing table, there'll be more focus on the numbers. But as all OEMs do recognize that a difference in quality between different tool rooms, and these cannot come without money. There is no charity, right? Everything is costed. So it is not necessarily true that every time we'll go for the cheapest option, right? Having said that, what we look for is definitely we want to look at the strength of the engineering team in tool rooms.
Okay.
That's a starting point. Uh, how many people you have, what are the qualifications of the people, what is the experience of the people, what are the kind of projects they have worked on. That is a definite starting point to say what is the engineering might of the tool room. And when I say that, it also is about what is your basic understanding in how good a simulation you're able to do. Because what is happening in the electric industry is, because it's a sunrise technology, everything is a ground up design. We are
Right.
not taking it, we are not doing incremental innovation where you have an existing platform, you just work on it and tweak it, right? What happens in many platforms is it's an incremental innovation, whereas it's a ground up a sunrise technology. So it is all based on first principle based engineering. Okay. Even Tarun's reel that you can probably go back and see, which got released a couple of days back, he speaks about first principle based engineering. So many of these industry are first principle based engineering, which means we rely a lot on simulation technology. The world is going towards digital. The world is going about IoT. The world is talking about digital twin. So before we create a real tool, we want to create a digital twin of the tool. Okay. Uh, I'm sorry, I'm not going to talk a lot about digital twin in this forum. I believe many of you may understand what is a digital twin, but if you don't, I would honestly urge every one of us to go learn more about digital twin. Right, the digital twin is a virtual twin of what you do physically. Right, I'll just say like that. Right, so
Right.
the when we put new lines, we want to make digital twins before you put the lines. Similarly, in tooling also, we want to make a digital twin of the tool to say how does it perform before we start cutting the tool, right?
Okay.
So I think that is something we are honestly looking for. Other parameters, I think you know, right? What is the quality of the machines? What kind of machines you have? What is the precision level of those machines? I think those are common denominators. But because of the accuracies we are looking for, we are also very keen to look at uh, what kind of machines you are using for finishing stages. Uh, Last but not the least, there is another unique requirement we have started to look for, which is called concurrent or simultaneous engineering.
Okay.
That the need to bring the new product to the market is getting smaller and smaller, right?
Right.
And
Right.
trust me, we are not alone in saying that. I was speaking to my peers in the tooling industry. They were talking about how Mahindra is talking about concurrently doing the tooling when the design is getting mature, right? What we mean to say is when the product is like 60% mature in the design, we want to kick off the tool design activity, right? And
Right.
simultaneously iterate, and the last 30% of the product design and the first 30% of the tool design, we want that to happen simultaneously. Okay. That is something we are really looking for, right? Where the market is used to saying, you complete the design, give it to me, I will start doing that, right? And we are also getting to a point to mature enough to understand, saying that, hey, if you're going to give a quote with a lot of assumptions, and if there are changes that's going to happen to my design, because I'm concurrently changing the design when you started to, we're also creating those points to go back and revisit the numbers you are giving. So we are mature enough to understand that, and we won't say that, hey, this is a number you quoted, I don't care, you go and deliver, right? That's where we as Ather are going towards. Those are the critical points we look for when we source tools. Nishan, did I answer you?
Yeah, yeah, of course. So, one of the things that you spoke about is digital twin, and as you said, that is still very much in nascent stage in India. It's very, catching up. So, do you have any supplier who is giving you, digital twin environment where you can review the whole, setup and the product?
For the lines, for the manufacturing lines, for the battery assembly lines, yes, we do have that. Okay.
Okay,
But I think there are not enough players to do on the tool front.
okay, okay.
Okay. Of course, the if you talk about simulation, um, which is the one level of simulation which everybody does now, right? Which is mole flow, right? Even mole flow, I would say probably I want you guys to challenge me on what I'm saying now. I don't want to get away by saying this. I want really pushback from you guys on what I'm going to say. I think there is a gap even on how much intensity of mole flow you can do, right? I know mole flow costs money. Nothing comes free, but there is usually a certain set of assumption taken that I'll do 2 iterations. Sometimes in the current scenario, we may have to do 5 iterations, 6 iterations, and I'm not saying it should be free, but we uh, yes, commercials is one aspect, but technical is another aspect. We should find a way to marry, which means we should be able to continuously work with each other between the commercials and technical teams. Say that, hey, have I reached it? If you have not reached it, should I do more simulations to get to the right point? I think I have not seen my expectation on how far a tool rooms do more flow. I'm still. I think there is a gap. And as I told you, I'm extremely open for pushback from the team to say, no, we are doing it. Probably you're not saying it. Okay, I'm perfectly okay for a pushback, and I'm ready to get recalibrated on that. But I still think there is a big gap on the mole flow, right? And then we talk about digital twin, where you can completely. It is up to the tool rooms to create that opportunity, and once there's opportunity exists, I think suppliers will evolve. It's a question of supply and demand, right? Once the
Right.
demand comes up, of course, there are going to be companies which are going to step up and saying, I'll make a digital twin for you. So to answer you, do I have an answer on who is the supplier of a digital twin? No, I don't think
Right.
I have an answer for you. I have an answer for the manufacturing lines, but not for tooling.
Okay, okay, okay. And you are sourcing it, and then you also set your expectations from the tool makers. But as the demand increase for do you also plan to do some sort of captive tooling in-house, in your company to make a lot of tools, or you would still like to source it?
So I will give you my view as it stands today. Okay, but times may change. The equations may change, right? I think I still I'm aspiring. Eventually, we want to put a tool room, but this tool room is not to meet the needs of Ether, right?
Right.
Because I don't think anybody will be profitable saying that I will do complete tooling in house for me, right? Um, uh, as tool room, as people who run the tool room, you know the cyclicity. Even when you have multiple customers and multiple, you have cyclicities, right? And as OEM, if we have our own tool rooms, I don't think we will be economically making use of the resource we have, right?
Mm.
So, but when I say I want to have my own tool room, a small tool room to make some quick engineering changes, some small engineering changes that you want to do, small corrections you want to do. So probably I'm aspiring to put a small tool room to do that, but that is not going to eat into your pie, right?
Right,
That's
right,
not going to eat into the pie of tool rooms.
right. So, you also have experience working with the overseas tool makers and the Indian tool makers. What are the fundamental difference you find working with the overseas tool makers versus the Indian tool makers? Where Indian tool makers still need to work hard to match the level, or they are still there? Maybe you can provide your views on that.
I'm going to say something from my current paradigm. Okay, I am
Right,
wearing a set of glasses and I am seeing the world through my set of glasses, and I am going to say talk from my perspective. Right. Um,
right,
the first starting point is lead time, right? And I don't want to go into the topic of China, right? We all know that China has got excess capacity and there is no queuing at all, which means you can get the tool at much faster time. So if we all of us keep talking about China, I think we'll keep justifying why the lead times are shorter, and it becomes a self-fulfilling negative prophecy, right? So I do not want to start the topic with China. Okay, I want to
okay,
start the topic with Taiwan and Korea, right? Taiwan and Korea do not have the same economic conditions that exist in China, where they got surplus capacity, they got machine standing, so there is no queuing. But China, Korea, and Taiwan continues to lead in terms of lower lead times. Okay, and I know that the biggest tool room of India may still look like the tiny tool room in China. I've heard those stories and I've seen it also. That's why I'm ignoring China. but there are very good examples that I have worked with Korean tool rooms, very small one, which can really crush lead times. Okay, and again, I don't want to go and say bago, 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 run fast, right?
Right.
It's about how we how the two things I've observed with those companies is they run tool rooms like they run manufacturing, right? They're extremely bothered about downtimes. They're extremely bothered about the uptime. How much is my utilization? They keep the machines on their toes most of the time. Okay. I'm
Right.
not
Right.
saying Indian tools are not doing it. Don't take me wrong. I'm only taking the good example of what I see in Korea and Taiwan. If the Indian tools are doing it, I'm very happy to hear it. But I attribute the Korean and Taiwanese lesser lead time to two things. One is uh, how they diligently ensure that the machine is always up. They push more and more steel, aluminum out of their shop floor, right? So that reduces the lead time that they offer to customers. And I have seen many tool rooms, even small ones, run their machines 24/7.
Right.
So they went to CAM operated automatic machining, which is software based, not very expensive. Uh, all the roughing happenings 24/7 throughout. Okay. Sometimes I believe, probably all our tool rooms are not doing it, which also reduces their profitability and also increases the lead time. Okay. So my own thing is the queuing is the biggest portion of the lead time. I used to hear 12 to 14 weeks for T0 sample 15 years
Yeah.
back. I continue to hear the same thing when we talk to my own teams. That 12 to 14 is a magical number, right? For most of the tools, I hear this 12 to 14 weeks is a lead time. Whereas we hear 8 to 10 weeks or even lesser if it is Taiwan, China, Korea. Sorry, I
Okay.
mentioned China. So Taiwan and Korea.
So, right. 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 So before I ask the next question, I have a request from the audience. If you have any questions, please put that in the chat box, which Mr. Ramesh can address at the end of our conversations. So next question, Mr. Ramesh. Could you share insights into the specific expectations that Ather Energy has from the Indian tool makers in terms of its quality, innovation, delivery to meet your demand? Because today you are making X number of pickers, and tomorrow you are going to, of course, increase it. It could be 2x, 3x, and you will also export in future. So what kind of expectations you have and what kind of suggestions you have to the tool makers?
So my request is I want to make an earnest effort as Ather to bring the tool rooms and work with us when we are in the final stages of design. Right. Many times what happens is our engineering teams make a design and then we try hard to make it happen. Okay. We have found a lot of benefits when we launched the fast moving 450X version in November 21. Some of the most difficult challenges we were able to crack it by our engineering teams, the tool room, and the raw material supplier working together during the final stages, right? Uh, so I think that's not happening automatically. Even now, when we have the challenge, I'm going to go and remind the teams to collaborate and work together, right? As industry folks, I think we should focus more and more on collaborative engineering. I think it will reduce the development effort. It will help us get better parts, better quality, and faster to the market. So I think that is something all of us have to work together on, which is the collaborative engineering. The second portion is simultaneous engineering, right? How I can uh, start manufacturing or designing the tool at least, even when the design is 60, 40, 60, 70% ready, right? How you can start and iterate the design of the tool when you go by. So if you really look at it, we have every company has got a milestone called tool kickoff. We have 4 milestones. I'm sorry if you find this stupid, but I think we are trying successfully to work on this model. We have something called tool sourcing kickoff, tool
Okay.
procurement kickoff, which where you start procuring the long lead items, tool design kickoff, and tool cutting kickoff. So we are converting into 4 different milestones to ensure the tooling people are start to work when our design is only 70% mature, right? The idea is not to say bago and get the tools faster. If the lead time for making the tool is 15 weeks, so be it. You can take even 17, 18 weeks, but you start the lab little earlier, right?
Okay.
You start running with us earlier. So for us, when the design release happens, we still get the part in 8 weeks time without stressing
Okay.
you, without making you to go faster and faster. That's what
Right.
we're attempting to do, and we are putting a structure to the method. And I know from my colleagues in the field and my own experience working with Nissan when I was in Visteon. Nissan used to do it. Uh, Now Mahindra is doing it. Many OEMs are following this pattern. Probably all of us have to come together to make it as a very structured process.
Okay. Okay. So till now, how has your experience been working with the Indian tool makers? Have you ever faced any issue? If you would like to give an example without naming a company or something, has it?
So I won't say I've had a bad experience, honestly. Okay. I don't have any bad experience today. I did not get this. No, I don't have that. I think it has been a good journey so far. But I'm not saying that I'm very happy with the journey. From whatever I have told you, my look at ideal state is a little different on lesser lead times and things like that. So I definitely want all of us to work together to do all this. But I
Right.
do not have any major negative feedback to share with you, Nishant. I'm sorry.
Right. No problem. And how do you rate the skill set of the Indian tool makers? Are they at par? And any catch up to be done? Any in
See,
specific areas?
I, what I'm going to say is a common challenge to all of us. I know the challenges we face, but if you go to a Western market, like a Europe or a US, you can come across a tooling guy who's like a seasoned guy with 25 years of experience. Uh, that is something we miss. And I know we have huge challenges to retain that, right? But even though we talk about, hey, I have a tooling guy, but he wants to go change his job within 4 years. He wants to keep moving. But if you also go to the Western market, uh, let's say I have a tool maker with 25 years of experience who can do things in a jiffy, right? But he's also paid on par with an engineer, right? So I'm not saying that you're paying less, guys. Don't mistake me. But I'm saying that what we really miss in India is that kind of a seasoned tooling guys who continue to be in tooling after 20 years. And I'm not talking about just tool designers. I'm talking about completely tool maker, tool designers, and tool makers, things like that, right? Uh, when I was still 26, 27 years old, I worked in a company called Lucas TVS, and I had fitters in Lucas TVS in-house tool rooms who used to make lamination tools. They used to work magic with their hands. Okay,
Okay.
I think I still miss those kind of people in our tool rooms today. Okay, uh, or if they exist, I have not seen them in the recent time. Probably it's my blind side, but I still miss seeing those 25, 20, 30 years experience tool maker who can do wonders in our tool rooms.
Okay.
And
Okay.
what I'm trying to articulate here is we may have to relook at how do you retain talent, right? A guy who has been a tool maker for 4 years is we want to jump and go to a different thing because he gets better salary there,
Okay.
right? And it will go back to the topic saying that, hey, if I pay so much, I will not be profitable. You guys will not give me the tooling money. I think it will be a vicious circle. Then I will go back to the topic of how we improve our own efficiencies, right?
Right. Just last question from my side. Since you have a huge experience in the industry, you are already sourcing a lot of tools and you are working with many tool makers. If I have to ask you to list those 5 suggestions for the Indian tool makers, in a very brief, just about 5 suggestions that you have for the Indian tool makers.
Rethink how you want to do engineering. Okay.
Okay.
I don't want to do five. Five will be a very long list. I prefer three. Okay.
Okay.
Uh, Rethink engineering, rethink innovation. Try to, I know a lot of things I saw in Tagma also, aluminum tooling or anything. But when we really go to the table, we don't see two, three technologies culminating into a challenge we are talking about. Okay. There's how you converge few technologies to provide a solution for a big engineering challenge is something I have not seen a lot of demonstration about. So I don't mistake me saying that there is no innovation, but how do you converge few things to get a solution is something that's still missing. So how do we drive innovation and engineering? Your mole flow or digital twin, everything is part of this one big pillar, right? Second,
Right.
how do we create a healthy pipeline of talent? Okay,
Right.
it's a big problem. The tool rooms always lose talent. Okay, uh, the OEMs come and poach people from you. You lose your best talent. So it's a problem for the industry. We have to crack that solid. So to say that, how do we ensure long term retention of talent? Okay. Third, I think we need to think very seriously tool making as how do you have drive efficiencies? How you identify waste? Are you applying lean techniques in running tool rooms? Like for example, I remember a long time back, Godrej trying experimented with something called theory of constraints using Eliashib Goldratt, right? I don't know what happened to that experiment. I'm not commenting on it, good or bad, but those kind of experiments to say that I want to try lean technology, lean methods to improve, to reduce waste and improve efficiency, which will feed into everything else, right? Once you become more, once you start making more money, you can decide to make your tools cheaper, or you can decide to spend that money in your engineering or in talent. Okay, so I
Okay.
think there's a lot of opportunity. That choice is yours, right? How you want to play. But so I think that's a third pillar that I would say that tools have to work on. Five will become too long here, honestly.
No problem. So thank you so much. It was nice conversation, and let's take some questions from the audience. And I see there are many comments, but not the questions directly. There is one question from Mr. Bharataj Patil. He's asking how many average HPDC dies are required for two-wheeler EV model of Ather?
Hey, this is a very dynamic number, right? And HPDC has got a life and all the stuff, right? So uh, it's a very specific question to a 450X. I'm very happy to have a phone call with you, Bharatraj Patel, with more data. I would like to have answered more generic questions, but trust me, we do have a lot of tool room requirements, the HPDC requirements. But currently on HPDC, we approve the tool supplier as a philosophy, we let the supplier select his own tool room. We are right now not directly sourcing the HPDC dies directly. Okay, not that we don't want to do, but we are not doing it right now. For plastics, we have started to do that.
Okay, thank you so much. Uh, guys, if you have more questions, please post it there. In the meantime, I'll read one comment from Mr. Gopala Krishnan. Yeah, actually, he's thanking you for recollecting the presentation during ITS on aluminum, die steel. There's a question from Mr. Karan. How do you gauge your tool suppliers? What percentage weightage do you give to productivity versus pricing?
So it's almost equal. It's
Okay.
almost equal weightage. I won't say productivity. I would say a combination of technology and lead time and pricing. Almost equal weightage.
Okay. 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 So I think Mr. Ramesh has also shared his direct number and email ID. Thank you so much, sir. There is one question from Mr. Shiru Ali. Most of plastic parts are designed by Ather or reverse engineering to be done from suppliers end.
No, it's completely, will give you a completely mature data, complete A surface with all B surface. You just have to reproduce it. No, I mean, I would glad to do it otherwise also, where I am able to give you a cast surface and joineries. You improve your value proposition by doing the CAD also. But as of now, we give you completely mature data, which you can directly start cutting. But I'm
Okay.
very open to say that, hey, I you give me a cash data, the basic thing, I'll do some, I'll improve my value chain and then do some engineering. I'm open to those conversations.
Oh. Another question from Mr. Satya. Are gravity dies used in making aluminum parts for two-wheeler industry?
Yes,
Okay.
yeah, I think gravity die casting we use for your wheels. There was a point in time few other parts of the vehicle also are gravity die cast, but we have moved it to LPDC wherever possible, and some of the LPDC have gone to HPDC. But I think wheels remain as a primary gravity die casting.
Okay, okay. One question from Mr. Manoj is asking, are there any press parts that you are finding difficulty to source it locally?
So no, actually there are two kinds of pressed parts. By pressed parts, I think you're talking about sheet metal, right?
Yeah, I don't know. It's not mentioned very specifically, but yes, he's saying yes. Yeah, sheet
Yeah,
metal.
I'll take it as sheet metal, but the more intricate sheet metal parts, which are the laminations for the motor, our suppliers are buying it, but most of the time they buy it from abroad for the
Okay,
motor laminations. But all of the sheet metal we do it locally.
okay, okay. Question from Mr. Gopalakrishnan. In a typical EV two-wheeler, how many parts will be of plastics and how many of aluminum approximately?
I think plastic parts typically, I'm ignoring some chotu motu parts, but typically will be around 42 plastic parts, and all
Okay,
casting parts, HPDC, LPDC, gravity dies, all put together will be approximately um, around 25. Um, Most of them directly used by us, some like a casing of motors and things like that, around 25 parts.
okay, okay. We have follow-up question from Mr. Ali. That's funny one. Any plan for Ather to go four-wheeler electric in future?
Oh,
Right. Right. So I cannot find any more question. Okay, we have one. Just couple of more question we'll take, keeping the time in mind. So we have one question from Mr. Balaji. What is the best field in the EV industry, die casting or press tool?
I would say press tool and plastics.
Okay.
Die
Uh,
casting, unless there is some big innovation like what I told you comes in, uh, even we may not use die casting in our next platform. Right?
okay.
It depends on where the industry grows together.
Right. Right.
Normally,
Uh,
any lens. So yes, we use lens mold
okay.
both in our lamps, and also we are now, if you look at 450 S for sugar, if you look at the 450 S, we have got a lens on the top or on the above the dash, above your display, right? So we do use lens. For the lens that we developed for 450 S, we made it locally in India. But as I told you again, all other lens tool in the headlamp, tail lamp, our lamp suppliers prefer to do it outside India.
Right. Any more question or we can go to the concluding note maybe?
So there was a question by Sanjay, where are you ready to give a chance? Yes, as I told you, we already doing the lens mold for 450 years in India. But if you really want to make lens for a headlamp and tail lamp, you need to convince my supplier also. Uh, because my supplier is saying, look, I will give you the timeline by going there. If I go locally, I can't give it. So I think it's going to be more collaboration, that you need to work with our lamp suppliers also.
Right. Right. Great. Thank you so much, sir. Thank you so much for sharing your wisdom with us. And few things I can pick up from our discussion is that you are quite bullish about the Indian tool makers. You have confidence on Indian tool making industry. And at the moment it is 80%, but I'm sure in 5 years, 2 years time, it will be even higher. And you of course have a lot of suggestions also on capacity and skill development and some sort of technologies, of course, using about the digital technologies like digital twin, industry 4.0, and also that's what you're asking Indian tool makers to incorporate. Thank you so much for sharing those information with you. Thank you so much to the audience for joining us today, and I hope you all learned something new. It was insightful and all. Thank you so much. This is Nishan from Tagma signing off. Thank you so much, sir.
Thank you very much. I given my coordinates, my email ID and phone number. If any one of you want to contact me directly for some reason, I'm more than willing to have a chat with you guys. Thank you very
Okay.
much.
Thank you so much, sir. Thanks.
Bye-bye.